Good afternoon, everyone. Specifically from this video part of Friday. I'm going to explain about a transfer which I was taken from ResearchGate, a method for increasing the productivity of the distributed file. So this is the introduction of this paper. So corporate networks are growing in a very huge large scale in recent years, and the complexity is highly risky. So when we used more device, it gives more risk of cyber attack. Traditional firewalls struggles to handle increasing traffic. High numbers of filtering rules, such like slow performance, delays, and packet loss. The paper process a distributed firewall using Proxmox LXC container to improve performance. Why does it matter for improving firewall? So this needed to in better security, less delay, handle more users, work with limited hardware. So problem statement, rapid increase in cyber threats targeting companies, limited computing resources not having medium business, traditional firewalls become bottlenecks during peak performance. Manual configuration of firewall rules with flow and error solved. Rising numbers of IoT devices increase attack surface. Need for firewall that is fast, scalable, and automatically adaptable. So we made it effective of this platform is to design a high performance distributed firewall that reduce delay and increase efficiency even with limited hardware. The proposed method, core idea, use Proxmox V and LXC containers to create a distributed firewall system. Key steps. Divide the network into logical segments. Create one LXC container for each segment. Run firewall inside container with your IP tag table. Distribute traffic filtering across multiple containers. Enable easy expansion by adding more containers. Benefits of each method: faster filtering, easy to scale, stronger regulation. System of one main Proxmox server hosts multiple containers. Each container behaves like a separate firewall. So these are the containers used in this project. So container one or three, one or three. The external network interface connecting to the internet. Internal interface connect each container to each server. So the advantages of this and how the architecture works is traffic is filtered close to the source, reduce load on single system, improves overall network performance. Software used for this project is Ubuntu 20.04 plus IP tables. Basic allowed services SSH port 22, HTTP port 80, HTTPS port 42, ICP, ICFP. So experiment setup hardware requirements. Core CPU at 2.9 GHz, 16 GB RAM, and minimum of 500 GB storage. Gigabit network connection at least two NICs, internal and external networks. So testing environment, three firewall containers, each serving a different subnet. Tools used NPM, route and delay testing, ICMP for connectivity, and finally is used to local web server for traffic testing. So purpose of this experiment, to know the purpose of experiment is to test delay, resource usage and scalability. So these are the results for this experiment. The key finding. More containers gives lower packet processing delay and distributed firewall significantly outperform a traditional single firewall. CPU and RAM usage remain stable due to the low distribution. High security levels. More blocked harmful packets, fewer chance of firewall overload. Model used queuing model for traffic analyzing and Jackson network model for multi-container communication. So the overall result of these equipment is distributed firewalls use faster, safer, and easier to manage. So conclusion. Main takeaway. Proxmox-based distributed firewall greatly improved the performance, reduced delay in traffic flow, worked efficiently even with limited hardware, scalable by adding more containers, providing stronger network segmentation and higher security, ideal for small and medium business. So possible improvement for future work, integrating monitoring tools like Prometheus and Grafana, automate detection of anomalies, reduce the deployment time of new content, add unwanted threat detection models, optimize resource allocation using smart algorithms. And these are the information I got from this paper. And thank you.